Hello, ladies and gentlemen, this is Mr. Santoro, and welcome to the screencast for infinite limits algebraically. So how do we find the limit as x approaches infinity algebraically? We've done that from the graph. Now we're going to look at how do you do it with an algebraic solution. So I have a few examples here, and we'll go through those, and as we go through the examples, we get the idea as to how we do it. So the first one we want to look at is what's the limit as x approaches infinity of the function f of x equals 2. So what I did, if you look here, it's 2x. So I started putting in values for x. I chose 0, 10, 50, 200, 500, 2,000. I just chose random values for x. Because it says x approaches positive infinity, so my values in the parentheses in place of x, they're all increasing. And you can see below, when x is 0, function is 0, when x is 10, y is 20, and so on. So when x is 2,000, the limit of the function is 4,000. So this function keeps increasing and increasing and increasing. So therefore we could conclude that the limit does not exist because as you continue to put values in for x, the larger the values for x, y will be twice as big. So you generally get the idea that the limit doesn't exist because it will just continue to increase and increase and increase. Okay. Example 2, the limit as x approaches infinity of the function f of x equals 1 over x. So then I did a similar thing here, and I said, okay, the number is going to be increasing because it's positive infinity. So I replace x with 2, 4, 10, 100, 1,000, and that's what I got. 1 over 2 is a half, 1 over 4 is 0.25, and so on. So this function, as x increases, the y is decreasing. And it's approaching the x-axis, which is y equals 0. It'll never hit the x-axis, but it wants to attain a value of 0, and that's why the value of this function will be, the limit of this function, is 0. Now let's take a look at something like as limit of f of x as x approaches infinity, the function f of x equals x over 2. So what I did is, again, I chose some random values to replace with x. And regardless of what value I put in for x, as the values of x increase, so the values of y, and that will continue to go up and go up and go up, so the limit doesn't exist. Because no matter what I put in for x, I'm going to divide by 2, and y will just keep going. So the height of this graph will be infinity, actually. So at that point, we conclude the limit does not exist. Now let's look at something a little different. The limit as x approaches infinity of the function f of x equals x squared over x cubed. So if we look at that, and we reduced it actually, because x squared and x cubed, when you reduce that, you have 1 over x. The larger exponent is in the denominator. Therefore, the limit of the function as x approaches infinity, the limit is 0. Okay? So if you look at this, the exponent in the numerator is 2. The exponent in the denominator is 3. This we could say this is bottom heavy. The larger exponent's in the denominator. So when that's the case, the limit of the function as x approaches infinity, the limit is 0. Example 5, it's the other way around. The limit as x approaches infinity of the function f of x equals x cubed over x squared. The larger exponent is in the numerator. So we could say that this function could be top heavy because the exponent of 3 is greater than the exponent of 2. So the limit of the function as x approaches infinity, the limit does not exist. So again, if we look at this, when it's larger exponent on the denominator, the limit will be 0. When the larger exponent is in the numerator, the limit will not exist. Now let's take a look at something yet a little different. 2x squared over 3x squared. So if we reduce this fraction and the x squareds cancel out, we're left with 2/3. That's the limit of the function, because the largest exponent is the same. It's exponent of 2. It's in the numerator and the denominator. So the limit of the function is equal to the fractions of the coefficients. So the x squared and x squared will cancel, and you're left with 2/3. That's the limit of the function. Now let's look at the last example. If we look at this, the limit is x approaches infinity. The limit does not exist. The question I'll be asking you in class on number 7 is, why is it that the limit doesn't exist? It's something I covered up above. So it's one of the examples that I discussed. So your job before class is to tell me why the limit doesn't exist. So if you need to replay the screencast, please do so, as usual. In class, we'll be going over the screencast, and we'll be also doing some practice problems. So thanks for tuning in to the lesson on infinite limits algebraically.